So in this we're just going to look at how electricity moves through the heart, and it does that through depolarization waves. So the obvious question is, what is a depolarization wave? That's kind of a weird sounding thing. All it is, depolarization is just making something less negative. Something that's already very, very, very extremely negative, just making a bit more meh. Yeah, it's negative, but just not as negative. It's kind of like taking something that's very extreme and just making it less extreme. So maybe taking, the poles here and moving them near the center. So D as a not polar, going away from the poles, ization. That's making it a noun. All right. So what this in action, what it actually looks like is something like this. You're gonna have to just bear with me for a second and imagine a crazy situation that I've thought of. I have loads of balloons here, and they're all negative, so they're all extremely negative charge. I've rubbed them in my hair like a madman. All of them. I've rubbed loads of balloons in my hair, and then I've tied elastic bands to them. I haven't done this, but I might actually do it some weekend. So the deal is, I've got these two. Let's just look at these guys for the moment. Alright, just these two. They are both negative and they're beside each other. So what should they do? Think back to the rules of attraction and charges. They're both like charges. They're both the same charge, the negative. They should either push themselves away or pull together. And if you said push themselves away, you're a winner, because opposites attract. They ain't opposite. They are like, so they have to repel. Like charges repel. They're going to repel. These guys are going to repel. Everyone's going to repel each other. They all hate each other. They're all going to run away, and the whole thing spreads out. So all these balloons spread out. Rightio. Now, what would happen if all these balloons now they're holding each other apart? Those elastic bands are nice and taut. What would happen if one of these balloons was depolarized? So by depolarized, I mean, as I said, making it less negative, less extreme. So we're going to take away some of his negative charges. What would happen to the guys around him? Well, the answer is they would fear him slightly less. So they would not repel him as much as they used to. So they'd probably move in a little bit to take advantage of that ground. And you get this contraction. And so that is the effect of what depolarization does. It causes a contraction. And if you think of this as, say, you're standing in a line, a load of people, you're all holding hands, pushing each other away. If you were to grab the person's hand to your right and left and suddenly just shove your hands into your pockets, so their hands are down in your pockets, which is kind of uncomfortable for them, but what actually is going to happen is the whole line of people are going to be pulled in by your action, and it's going to cause a kind of a wave effect. And that's what the polarization wave is. All these guys move because this guy decided to polarize. So you can spread a wave and doesn't have to go towards this guy. It can move along the chain, and this is a depolarization wave. Okay, so it's a contraction caused by something becoming a little bit less negative. So what has this actually got to do with human beings, or are we just going to be talking about balloons? Well, the way this works is that if you can imagine, as an analogy, there's the kind of balloons in here, in your cells. These are all negative, just like your cells are negative. The cells in the heart, especially cardiac cells, they are negatively charged at rest. So what happens is, if you depolarize one of them, you will cause a wave of depolarization throughout the whole cardiac tissue. If you just like the waves in the balloons, if you just decide to polarize one balloon, you'll find that wave carrying through the whole thing. So you'll get a contraction in the tissue, and it'll go bump bump, as we'll see later. Okay, so what we really need to do is just trace the journey of these signals around the heart, because it's kind of cool the way it does it. So there are two giant scary names you need to know here. There's one, the sinoatrial node, SAN, and two, the atrioventricular node, a tricky one to say, and that's the second one you need to know. Okay, sinoatrial node, atrioventricular node, AVN. The way this works is the signal, the depolarization signal, starts off here in the SAN. It flies around the whole top of the heart. I mean all of it, all down here, and around it goes, and they all meet back up at the second point here, which is the second horrible word, the AVN. So all of this tissue depolarizes in a big wave all the way down to the AVN. At the AVN, it calls in for coffee. It stops, reads a newspaper, looks out the window, reflects upon the day's events, and when it's ready, it gets back on its way. And that's because there's electrical resistance in the AVN, which slows it down and gives you that pause between the dum dum in your heart. So here we go, and it goes in an amazing W all the way back, and the thing resets. So let me just do this again. It goes SAN through both atria. The atrium is the top, like an atrium in a house, you know, up the top, and then calls in here on its way down. So they all come down to this point. They go round and down to the AVN. It pauses there because it goes through really, really, really slowly. Maybe there's a big Q or something, and then finally it moves on to the rest of the heart, like that. Okay, and resets. So that's the pattern. That's what it does. So could you put these in order? Well, let's see which makes sense. So the SAN, you can always go back to check the other bit. And the SAN starts the wave. That's about right, yeah. So the atria, what were the atria again? Oh yeah, these were the things up the top, like an atrium in a fancy building, up the top. And these depolarize. Yeah, okay, that makes sense. I'll put that second. Is this actually in order? Excellent. I think it is, because wait, let's see. The AVN delay, yeah, that's right, because it comes down and then stops in the middle. The atrioventricular node, very ventricular to say. And then the ventricles down here, they start depolarizing, and finally your ventricles reset, and the process is complete. Yes, that makes sense. Good. All right. Let's see if you can match that up finally with something on an ECG. Okay, so there's one missing here, so they're definitely not in order. Can you look at that and put them on the graph? Now, I'm assuming that this is going to be first, second, third, and fourth. Okay, so can you put these, all these four, in order in that? I just pause it here. Alright, let's have a go. Right, so okay, I'm gonna just do it all over the place. I know the ventricles reset. That's the bottom of the heart resets. That's gonna be right at the last bit, isn't it? Yeah, so that's gonna be down here. Okay, atria depolarized. So I guess what's missing here, it seems to be, doesn't seem to get picked up here on the ECG, is the SAN starting the whole thing. So it's kind of annoying that the first piece is missing, but meh. Alright, so I guess then the first bit, what would come after that, is the atria depolarizing, so the top of the heart depolarizing. Let's see, then there's that delay. Ooh, it doesn't look like a big delay. It's a tiny little one there. And then up the top, this big one, these must be the ventricles depolarizing. Alright. And that is it.